My name is Jacques Boudreau. In this presentation, we will go over an experiment that was conducted on a small-scale solar oven. 3 small-scale solar ovens are made, one with an aluminum foil base, one with a black construction paper base, and one with a cardboard base. The purpose of the experiment is to see which one will heat a small red potato the best. The small-scale solar ovens are made from a pizza box. A 10-inch square is cut from the lid and replaced with plastic laminate. The 10-inch square is folded upward to an 80-degree angle and wrapped with aluminum foil to serve as the solar panel. The solar panel is held up with push pins. The size of the potatoes used during testing was approximated to have a 1-inch spherical radius. The internal temperature of each potato was tested hourly using a digital food thermometer. This is the finished product of the 3 ovens. The oven with the black base is seen on the left. The cardboard base is in the center. And the oven with the aluminum foil base is on the right. A tiny hole was punctured into the plastic laminate on each oven so that the temperature could be tested easily. These are pictures from the day of the experiment. The outdoor temperatures on the day of testing range between 64 and 81 degrees Fahrenheit, and there were also 5-mile-per-hour winds. The data collected from each solar oven is shown on the left. The highest achieved temperature for each oven is boxed in red. The oven with the aluminum foil base was its hottest at the end of the day at 6 p.m., while the ovens with the black base and cardboard base reached its hottest temperatures at 1 p.m. A recorded temperature of 158.7 degrees Fahrenheit can be seen on the right, and this occurred in the aluminum foil base. The data from the previous slide can be displayed graphically in the figure. The x-axis represents the time of day on a 24-hour clock, while the temperature in Fahrenheit is displayed on the y-axis. The maximum temperature achieved by any oven occurred by the aluminum foil base at 6 p.m. with a temperature of 161 degrees Fahrenheit. This is a list of the materials used as well as the cost associated with the material. The experiment is fairly cheap to conduct, with the food thermometer being the most expensive item. The total price for the experiment is $34.56. The potato did not fully cook in any of the solar ovens. In order to fully cook the potato, an internal temperature of 210 degrees Fahrenheit would have had to have been achieved. Further research on solar ovens can be done to improve the temperature at which the oven can reach. For example, insulation can be used to retain the heat into the oven. Also, instead of keeping the angle of deflection at 80 degrees, different angles could be tested to see what works the best. On the left, the potatoes after the experiment can be seen. And on the right, the oven with the black base appears to have faded due to the sunlight from the experiment. The challenges encountered with the experiment primarily have to do with the outdoor elements and quality of the material. The 5-mile-per-hour winds on the day of testing does not seem like much, but it kept changing the angle of deflection between the solar panel and the potato. Also, the wind created a few challenges. The experiment originally had to be put off for 2 days due to the rainy weather and lack of sunlight. Also, on the day of testing, although it was fairly sunny outside, the sun would get behind a cloud every now and then, and it would make the temperatures drop. In conclusion, 3 solar ovens were made with different materials used for the base. The solar oven with the aluminum foil base achieved the highest temperature at 161 degrees Fahrenheit. The wind and other elements made the experiment difficult. The potato was not fully cooked because it did not achieve an internal temperature of 210 degrees Fahrenheit.